This is All Things Ansys, a podcast from the technical support staff at PADT, episode 134, a look at Ansys 2025 R1 and the latest news and events from the world of Ansys. Happy February, everybody. I don't know about you, but I like February because I don't have to say, doesn't this seem like a short month? It is a short month. So if you're a frequent listener, you also know that for a few years now, at the end of February, I go on the Star Trek cruise. So I'll continue to be hunting for Ansys users on the cruise. I know there's more out there. There's got to be a bunch of us on that cruise. It's also when Ansys releases their Q4 and annual numbers, and we will dig deep into those after the day's roundtable and Ansys 2025 R1. So a lot to talk about February related. I want to start by pointing out a kind of new resource on the Ansys website I've been able to help with a little bit that I've also found useful with our customers. It's called, and for myself as well, it's called Simulation Topics, and they're kind of high-level short posts that explain a topic that is simulation related. It's not heavy simulation focused, but it's simulation related. They're mostly like what is or what are articles they're not Ansys specific. So it's not like, what is combustion and here's what Ansys combustion does. It's really what is combustion. To give you an example, some of the titles are what is fluid flow? What is a drop test? What are electric bus bars? What is plasmonics? Or what is the advanced semiconductor packaging? So these are sometimes areas that I'm not a super expert in. I can go in there and, in a few paragraphs, kind of figure out what's going on. If you're an expert on the subject, you don't need to know what is, right? But if you're not, it's kind of useful. So I've found it, other physics that I don't know well, optics, I'll use it quite a bit, or to send to a customer or manager who's not an expert. Maybe you think your product needs a drop test, but your manager is not really familiar with the whole drop test thing. If they go Google on the internet, they're going to find a lot of sales stuff about drop testing, but that's not going to really help them understand what you do and what you need to do for drop testing. So this kind of, as an example, their article really goes into some detail about all the standards and why you do it, and then a little bit about simulation at the end. So check it out. I find it's not marketing fluffy, and some of the content is really, really good, and it's not too technical like a white paper. So it's kind of in between that marketing fluff and a white paper. So it's kind of useful. So up on that. But right now, after, last episode, we talked about last year's release of Ansys 2024 R1 and R2. So this month, we're going to talk about the new release that just came out, 2025 R1. It turns out that it's good timing because we could really feel the improvements because we were just talking about 2024. So we got a great group of people together. So let's listen in to what they think. Is a special note in the latest version of Ansys for structures, thermal, electromagnetics, electronics, optimization, thermal, meshing, performance, and a few other things thrown in there for fun. Welcome, everybody. We're here today to talk about the latest release of Ansys 2025 R1. We've got a great collection of folks from our technical support and application engineering team with us to talk about some of the products that came out. It's Friday, Valentine's Day, so happy Valentine's to everybody. We've got a little bit of a smaller group today because I think some people took the day off or are in meetings with customers, but I think we got enough to talk about some of the things that most people care about. So let's begin with, as usual, with introductions, and I'm just going to go around the virtual room here and call people's name. And so going alphabetically by first name, Alex, you get to go first.
Sure. My name is Alex Moody. I've been an application engineer at PADT for about 3 years now. My background is electrical engineering, and I cover the high frequency portion of the Ansys portfolio. So anything involving antennas, printed circuit boards, signal integrity, power integrity, things of that nature would fall into my wheelhouse.
Excellent. Joe Woodward.
Yes, I'm a chief engineer, simulation support. I've been with PADT for 23 years now. Mostly cover structural and meshing and scripting.
Okay, excellent. And Josh Stout.
Hey there. Yeah, so I'm a systems engineer at PADT. I just finished up 5 years at the end of last year. So starting to see some good variety of things. I'm a bit of a Swiss Army knife. I cover electronics, reliability, and thermal, as well as optimization and some workflow automation scripting types of topics.
Excellent. Yeah, lots of good other products category. Molly.
Yeah, I'm Molly. I'm an application and support engineer here at PADT. I've been with PADT for about 2.5 years now. I cover thermal desktop, Ansys mechanical, and our other tool, FlowNex.
Excellent. Tom Chadwick.
Hi, my name is Tom Chadwick. I'm one of the CFD support engineers here at PADT. I've been here for a little over 10 years now.
And Sina.
Hi, everyone. I'm also a CFD application engineer here, 8 years with PADT.
Excellent. And Tyler just joined us.
Hi there. So I've my background is in low frequency electromagnetics, and I've been at PADT for just about 2 years now.
Excellent. Very good. Well, so yeah, we're here to talk about, last time we got together, we talked about what we liked about the last release of Ansys. So now we're going to talk about what people need to know about the new release, the 2025 R1. Lots of stuff packed in there. I think I'm going to actually start. I think I'll start with Tyler, actually. We'll put you on the spot first. What's new and exciting on the low frequency side of things?
So I think that the most exciting feature came out in the 25R1 release is the ability to now model axial flux machines in MotorCAD. This has been a capability that's been asked for a long time, and it's finally here. It's in beta, so it's not fully worked out yet. But the fact that it's now available as an option is a huge boon to electric machine designers.
And I have to ask, I'm assuming an axial flux machine is like a solenoid. Is that correct? Or what is an axial flux machine?
So it's a motor generator design topology where the magnetic flux is in the same direction as the shaft of the motor rather than radially outward. So it's just a different machine topology.
Oh, okay.
Useful for different motor design requirements. It's a harder to model system, but it has advantages for certain applications.
Okay. So I was wrong, but that's good. Good to know. Anything else other than adding that capability?
Beyond that, just general improvements to efficiency map generation between Maxwell and MotorCAD.
Okay.
And then some updates on solve times and things of that nature.
Okay, good.
But that's the big one.
So yeah, I guess my ignorance here, MotorCAD has its own solver. Is that correct, or does it solve over in Maxwell?
So it does both.
Okay.
Both has some finite element analysis built in for some 2D cases, as well as you can export your models to MotorCAD or to Maxwell to then do full 3D analysis.
Okay, excellent. Cool. Very cool. So what about the Maxwell side of things? Anything cool and exciting there?
So the biggest one is, again, motor design related. There's a new feature that was added in the previous release called Continuum Air, which helps to mesh the air gap between your rotor and stator. Okay. Previously, that was only for 2D models, and it's now been expanded to, again, as a beta feature, be useful for 3D models as well.
Mm-hmm. Very cool.
So that's the big update there.
Yeah, my little bit of experience modeling motors back in the old days in Ansys was now making mechanical APDL. Was modeling that gap was really hard. Getting that mesh in that gap was really hard. So see that as being important. Good.
Yes, very much so.
Yeah, tiny little area. Well, cool. Anything else you want to add for the low frequency side before we jump over to your high frequency brethren?
Those are the main updates that I've seen so far. I'm still playing around with the tool, learning more about what's going on. Okay. So hope to have more updates in the future.
Excellent. Very good. Well, let's stay in the electromagnetic realm of things. And Alex, what do you got for us on the high frequency side of the world?
I've got a few different things for a few different tools. So let me start with my favorite, HFSS. I mentioned in our last podcast recording that there's been a bunch of array features added to HFSS. So I don't want to spend too much time on that, but I will just mention again for any audience members who didn't hear last episode, there is support now for multiple antenna arrays in one design, and it handles sparse arrays much better. So sparse arrays is where you have elements missing from the grid. It doesn't have to create a huge air box to cover these missing elements anymore. So it handles it much more efficiently in terms of the meshing. So that's good on the arrays. But beyond arrays in HFSS, there's also been some enhancements to Mesh Fusion. And Mesh Fusion is the idea you can bring in a bunch of 3D components and then put them together and form an assembly. And that works really well for making your simulation more efficient. But in the past, there's been issues with inevitably some of those components interfering with each other in terms of their geometry. And how that was handled was maybe not the best way. So in this new version, 25R1, there's now a priority system for all of your different components. So you can decide which components should have higher priority so that if they do interfere or intersect with each other, the higher priority component takes precedence and won't throw a whole bunch of errors and warnings at you. So that's a nice new feature in HFSS. And then real quick, I just want to touch on 2 other tools that don't get as much love, but one is SI Wave.
Right.
SI Wave has had a couple of improvements in terms of performance. So one that's sort of late to the game is the AMD math library support is now there for SI Wave.
Okay.
That's something that came out, I think, a couple releases ago for the tools in Electronics Desktop. But SI Wave is kind of an odd duck where it sits outside of Electronics Desktop. So it's just now getting this AMD library support in this latest release. So if you do run SI Wave and you do run it on an AMD processor, you'll probably see considerable speed ups on that. And there's also another optimization to the solver input file. So when you bring in your PCB and you want to solve it, that board is represented by an input file that's fed into the solver. And there's been some improvements to that to make that file much smaller, which for very large PCBs will result in significant time savings on your computations. So that would be another big one for any SI Wave users out there. You should see some pretty considerable speed ups on both of those features. And then last thing to mention, just Q3D, which rarely ever gets talked about. There's a new feature that you can now simulate radiated fields in Q3D, similar to how you can in HFSS. So this is a beta feature, it's new, but the idea is you can now look at your far fields in Q3D rather than having to redraw that geometry or resimulate in HFSS. And so you're probably not going to design an antenna in Q3D, but you might be interested in like electromagnetic interference. And so now you can get those fields right natively in Q3D. So that's another really cool feature.
That should be a big time savings. Yeah, I can see that. That's cool. Very cool. Well, they've definitely been busy over on the HFSS side of things. That's really, really nice. Let's go and I don't know, Molly, why don't we it's not really related, but let's jump over to the world, a relatively new tool in the Ansys toolbox, thermal desktop. What's going on there? I know there's a lot of work going on getting that integrated and more into the Ansys world of things.
Yeah, absolutely. So I think my favorite feature that got added in 25R1 is the new launching app. Previously, if you wanted to launch Thermal Desktop, you would have to have a drawing file saved already, and then you would double click on that file. Now there's a new launcher, so it will create the drawing for you, and you can plug in like your thermophysical properties and your optical properties, and it syncs all of those databases up and creates the new drawing file for you. So I think that's going to help a lot of new users, especially because one of the frequent questions I get from new users is, well, how do I open Thermal Desktop?
Exactly.
So
it was not intuitive. Yeah.
No, it wasn't. So I think this is going to help a lot. So I'm really excited about that feature.
Good. Excellent.
One of the other improvements that has been made is that now we have second order elements for finite element method in Thermal Desktop. Previously, we only had first order elements. So this is going to help a lot with accuracy and just creating better meshes in general. There's also, your standard solver time improvements and just a lot of performance improvements have been making. So I think that might be worth upgrading if you're running with large models. I've heard they've seen up to 4 times speed improvements with some models they've tested.
Well, and I'll add, if you're one of those folks that's using a pre-Ansys version of Thermal Desktop and haven't wanted to make the transition over to the Ansys version, now's probably a good time to get back on Tex and get these newer ones in there, because some significant efficiency from a user interface and solving time, I think.
Absolutely. I think they've also made a lot of improvements with TD Direct, which is their SpaceClaim plugin. So now we can do a lot of meshing in SpaceClaim rather than the mesher in Thermal Desktop. They've actually removed that TD
Okay.
mesher.
Oh, great.
know.
Okay.
Yeah.
That's
So-
good news. Yeah. The
Yeah, it's a lot
Autodesk,
more
the old Autodesk
user-friendly.
product. Yeah. Yeah.
Well, you still have to use AutoCAD, but
Okay.
the mesher tool is a lot better now. So
Okay.
I'm happy about that.
That's a big improvement. Yeah. So it's time to take a look. That's really good to know. Cool. Anything else in the thermal desktop world?
So the final feature that I'll plug that I haven't been able to play with personally yet is new integration with OptiSlang. I think Josh could probably speak a bit more to OptiSlang, but I'm really excited about that. I think that's going to help a lot of folks who are running parametric studies.
Cool. Not only is that good to know, but it's a fantastic segue over to Josh. Why don't we start with of the blades in your Swiss Army knife? Let's start with OptiSlang.
Sure. So, like the OptiSlang specific updates this time around are actually relatively light. They have some performance improvements, things like that. As previous years, there have been more, I would say, flexibility and usability improvements in general. So things like PyOptiSlang, they've continued to expand. As Molly mentioned, some of the other tools have enhanced OptiSlang features within them now. So that's not really an OptiSlang specific thing, but just kind of tangential to it. I would say the one thing that I'm probably most excited about this time around is a feature they've been teasing us with for probably the last 2 years, which is SSH remote connection capability. So it's a pretty typical use case where someone who's running OptiSlang, they want to run either a lot of simulations in parallel or maybe a few that use a lot of cores. So they would typically run OptiSlang on a local machine and then solve those jobs on some remote HPC resource. So we could certainly do that before, but that was primarily done through PuTTY connections. So there was a node specific for that instead of OptiSlang.
Yeah.
Yes, and it required quite a bit of configuration and tweaking to make sure it worked. So the new feature is an SSH profile that's built directly into OptiSlang, so hopefully you can set that up once, and then any node that you want to execute remotely, you just say, use this SSH profile.
Okay.
So I'm really excited to kind of test that out and hopefully find that it works more robustly than the old system. But definitely something to look for.
And for users who aren't familiar with that, SSH is a secure shell, that an encrypted shell between machines that allows you to log in on the command line level to the other machine and run stuff over there. So a great way to run on across multiple networks without some fancy management tool. So that's cool. Very good.
Yeah.
So what else?
Yeah, I mean, that's it for OptiSlang.
Okay.
A couple of the other tools that I do work with, kind of going back towards electronics, there's actually been quite a bit added to IcePack this time around.
Oh, okay.
So first thing that I would mention, we had kind of known this was coming, but actually this is the first release year that there is only an electronics desktop version of IcePack. So classic IcePack has officially been sunset. It's no longer part of the install package.
Take a moment of silence for the old ICE and CFD interface? And all right.
Yeah, just a moment.
No, let's not.
No, we don't need to take any moment of silence. We can rejoice. All right.
Yeah.
Very cool. That's good to know.
Yeah, so it had its perks, but I think it's pretty much been superseded at this point.
Yeah.
That being said, there have been huge improvements this release for importing old classic IcePack projects. So that used to take a little while, depending on how complex they were. Some of the benchmarks they've provided with this release are showing 1 or 2 orders of magnitude improvement in time to load those files. So certainly that makes the transition, more palatable to the people who are being forced into that now. Capability-wise, they're adding a bunch of new stuff around PCBs as well. So of course, that's really the selling point for IcePack. So having more flexibility around that is great. So for instance, IcePack is really known for its accuracy in trace mapping. So that was kind of the typical application, but now we have the ability to choose lumped approximation. So when you don't need that much accuracy, it's nice to be able to do things quicker. So I'm really looking forward to that. There's also some new functionality called zoom-in modeling, which I frankly am shocked that I haven't seen advertised more. It's kind of like an approach to multi-scale modeling in IcePack. So if you solve something at a larger system domain level, and then you want to change something about one of the components, you can specify that you want to zoom in around that component and basically fix the field solution around that area, and then change something inside of it and rerun. So it should be really quick turnaround for small adjustments like that rather than having to reinitialize and resolve the entire domain. So
Yeah, 'cause
good
that's what
stuff like that.
you kind of had to jump out into another tool and do by hand, right, in the past. So that's really good to know. Yeah.
Yeah, I mean, honestly, I'm not sure how you would even do that problem in IcePack without this feature. I mean, you would just have to resolve the whole thing.
With a more refined area, yeah, or different area. Very cool. Nice. Okay. Anything else? Any other stuff you work with?
Yeah, one other thing I'd point out, still in the electronics-ish realm, is Sherlock.
Yep.
So Sherlock is primarily a structural-based reliability of PCBs and solder joints on those PCBs. There's almost always been ways to be flexible with Sherlock where you would use it to build up a mechanical model and then do whatever analysis you want in it. So that part's not new. And that part has been related to doing actual thermal mechanical finite element analysis. So you could use Sherlock to build up the model, run the analysis, do your own post-processing. This release, finally, Sherlock has a thermal mechanical capability built into it for finite element analysis of BGAs. So ball grid arrays tend to be difficult-ish to put together just because they have a lot of pieces. But now we can kind of automate that at several different levels of fidelity using Sherlock and run an actual analysis on it. So I'm pretty excited for that.
Very cool. Does that include solder ball fatigue, or is it just the basic thermal stress type stuff?
So this will be, it's not like full viscoplastic solder fatigue, I don't think, but they're using another method to kind of approximate that.
Oh, good. Excellent.
Yeah, so we are actually modeling the solder balls under a BGA, but they're doing some other math to kind of turn that into fatigue values.
Excellent. Very useful. Yeah, back when we started doing that and it was a 10 by 15 ball array, it wasn't so hard, but now there's a lot under those chips. So
we're often talking about half a thousand at least.
Yeah, that's crazy. Yeah.
Well, and that actually leads into one of my favorite things now is the new meshing workflows inside mechanical. And one of the things they point out is for ball grid arrays, where you can mesh just one ball, bring the boards in, mesh one ball, and then read in a CSV file with vectors of where to copy all the other balls. And then it'll copy those around and then connect that mesh to the boards. It looks really cool.
Yeah, as you know, Joe, we used to write some very complicated scripts to automate that process. Right. That is fantastic. That is really good news. Yeah.
Yeah. People don't know about the mesh copy. If you have a bunch of parts, components in your model that are copies of each other, that mesh copy saves a huge amount of time. Just meshing one piece of geometry and then it literally just copies it wherever else it needs to. So they've really improved that. Some of the other meshing stuff that they've added on, one of the things that caught my eye was they now, in Discovery, you can do show sweepable bodies. So that you don't have to go to mechanical, show sweepable bodies and see, oh, wait, I missed a couple. I got to cut something else up and go back. You can do all that in Discovery now, so that you can get all your bodies sliced the way you want them and put back together and then go to mechanical. That should save a lot of time.
Very cool. Yeah. Anything else on the meshing side of things? Those are both very useful.
Well, there's just a lot of improvements on just overall meshing shapes and like the multi-zone has the medial axis decomposition, so it just gives you better patterns to follow over long pieces. So that it'll they always show a helical spring. It gives you a much better pattern on the ends to follow all the way around, and that also helps with like slicing up a model to where you have a lot of radial bodies. Those get better shape on the split surface. The surface mesh is better to then sweep around through the radial body.
Yeah, and a classic test case. It's really difficult to do. That's great. That's really good. Yeah. Awesome. Good. All right. So that's meshing. Why don't we go ahead and dive into the two larger products? I think I'll go with eeny, meeny, miny, mo. Let's start with structural. So what's new on the Ansys mechanical and mechanical APDL side of things? Thank Joe or Molly. Yeah.
Yeah. There's quite a few enhancements to the topology optimization.
Oh,
I haven't gotten to play with all of them, but there's quite a few in there. Just different methodologies and things that are coming in. Molly, you got some off the top of your head?
I think kind of going back to meshing, I really like the new stacker mesh. It's kind of been around a while, but in beta. It's super handy if you're dealing with any electronics workflows for structural. It just makes meshing so much easier. It basically creates your hex mesh for you. It's great.
Yeah, and that's that ball grid array example they had. It does the ball grids, and then the stacker mesh gets used on the boards.
Very cool. Okay. Anything else?
Nope. There's just so much in there.
Lots of little stuff. Yeah.
I'm scanning through the update just for structural. It's a 320 page updates.
Yes.
I know they're making a lot of efforts on the smart fracture crack.
Okay.
Technologies. And one thing that I got to see a demo of that's not specifically structural or mechanical, it's the Ansys remote solution viewer. I don't know if anybody else has heard this. I got to see a demo of it. Basically, when you run on a cluster, being able to pull back your in post process without having to pull back the huge results files, so that you can go in and just tell it, I want to see these plots, and it goes off and grabs all the data, and it doesn't even have to be a compiled results file.
Okay.
It can read it off of all the cluster nodes, all the separate results files,
okay,
and pull the data. It was really cool. I'm looking forward to seeing that more here in the near future.
Okay. Very cool. Yeah. All right. And you brought up a good point. There's so many enhancements in all of these tools, especially the older ones. There's a lot. So we always recommend, I always like to point out, you need to go check out the release notes to find the ones that you care about the most. These are the ones that we are paying attention to, but there's a lot out there. Yeah. Anything else on structural before we move over to fluids?
I'm sure there is, but nothing I have.
Nothing jumping out. Yeah, and as usual, speed improvements. I think I read somewhere about some GPU stuff with some of the new GPUs. And I'll bring that one up. We may actually do a separate podcast on this, but if you've not looked at HPC in a while, every release they kind of chip away at making it better and better. So it's probably a good time to kind of set back and go, what if I go with one of these GPUs and a bigger machine and how much more memory? And I think you can get some pretty amazing speed ups these days and in all the products, right? I think it's not just mechanical. I think it's across CFD and HFSS as well.
Right. Yeah, definitely. I saw for structural side, they're getting support for multiple GPUs, which I believe they've had for the fluid side for a while.
Yeah.
So definitely speeding up things across the board.
Yeah, and when the AI guys started doing their own chips instead of using GPUs, custom built AI chips instead of GPUs, the price will come back down again. So we can go ahead and take advantage of that. So that's good. All right, let's go ahead over the fluid side. Sina and Tom, what are you guys excited about in the latest releases?
I was going to say that just continuing on that same vein of the GPUs, one of the things that the main focus, I think, in Ansys has been adding more physics into the GPU capability. on the
Gotcha.
fluid side, they've added combustion. They've added some acoustics capability, is now capable of being run on the GPU. They're doing radiation modeling now, discrete phase modeling, volume of fluid modeling, and even compressible liquids are all being done, can now be run on a GPU system. So that's been a big focus of theirs, is just, they had the original product, the base capability could run on the GPU, and every release they're adding more and more capability into what can be run on a GPU. So, if you haven't been able to run your model on a GPU, check the latest release. They'll probably have added your type of modeling into the GPU capability.
Yeah, these things kind of tend to sneak up on you, and you're like, "Oh, I don't use it because when I tested it 3 years ago, it didn't work." Yeah, I got to do multi-frequency or multi-spectrum radiation. Well, it's there now, right? So
yeah,
that's cool. Awesome. What else?
Just add a little bit in the user interface and user experience. Desktop interface is improved. Some cool features, and especially if you have like cases with thousands of zones, it's much faster now to use the desktop interface. Also, the web interface has new capabilities. There's more possibilities with the full remote sessions from mesh generation as a beta feature all the way to the post processing. So that has improved also. CPU, there's a cool new feature. They call it burst to cloud, and you can basically submit your jobs from your local case that you have set up locally on your machine and desktop. You can log into your Ansys account and submit to the cloud and run it. So a lot of new user experience and user interface improvements besides GPU is a big thing. Yeah.
Very nice. Okay.
Yeah.
Cool. Yeah. And some of the other things, they're gradually they're moving more and more stuff over to Fluent. They're
from CFX.
doing more turbo machinery. Yeah. More turbo machinery capability is in Fluent. They're expanding the icing capability in Fluent to allow for modeling of icing in aerospace simulations. Let me think what else. The battery modeling, one of the things they've done to improve battery modeling is that used to be that, you could mesh, when you tried to mesh a full battery pack, you had to mesh each component separately. But now, since a battery is very often a repeatable set of pieces, you can mesh one and then copy that mesh, and it will link the mesh up. So you don't have to spend time meshing all of the battery itself. You just mesh one individual battery pouch and then copy that through and add in the other components that connect the different pouches together.
Okay.
So that's a big improvement.
If you're doing batteries, that's going to be a big lifesaver. Yeah.
Yes. Let's see what else. One of the things they've talked about, it used to be that as far as CFX goes, the blade modeling for turbo machinery, they're adding a lot of capability in there. They've added an interface into Discovery for their Blade Builder product, just came out last year. And now they've got an interface in Discovery that allows you to visualize and build a complete 3D view of the blade geometry.
Cooled as well, or just the external surface?
Just the external surface. Although one of the things they're doing is they started, I think it was a year or two ago, they added in the capability. TurboGrid, which is the turbo machinery meshing tool, typically builds hex meshes around the blades. But the problem has always been it's a fairly simplified geometry representation. You don't have the ability to add in tip clearances and other tip features or radiuses, things like that at the hub. Now they've got a capability to do a combined meshing where you mesh the majority of the blade in a hex mesh, and then in the tip and hub region, you can add in a tep mesh.
Nice. Okay.
And it's a seamless interface between them. It's not like two separate meshes.
Right.
It builds one continuous mesh for the whole thing. So it allows you to add in a lot of extra features. A lot of times they do, in the tip of the blade, they'll put relief features and things like that in a blade, in a more complex blade geometry. So that capability is there now as well.
I won't even bore all of you with the discussions of the old days when we did that by hand and painful, and wow, I'm so glad to hear that that's working. That was a lot of work. Good. So many cool improvements. What else? Anything else on the CFD side? Just more little things. So check out the release notes there. Okay, what did I forget? Anybody have anything that we didn't cover? They're pretty comprehensive. Cynthia's going to join us probably separately to talk about all the stuff going on in optics, because there's quite a bit there. But anything else? Anybody have anything else?
I would just note that all the increase in Python and all the different modules and things, the enhancements to all the modules and just it's amazing how much they're putting into it.
Ansys is really taking off across product line. Yeah, for sure. Cool.
Then I had one other quick note. Relevant to quite a few people. They've changed the installation process again slightly.
Oh, okay.
So the big thing that's different this release is that the electronics installation has now been basically integrated with the rest of Ansys. So it's not a separate folder, a separate location anymore. So that is both exciting and terrifying.
Yeah. Well, if you're a company like ours that uses all the modules, I was approving a new machine, and I'm like, do we really need this much disk space to put Ansys? And they're like, yep, there's a lot of tools now. It's pretty amazing. Yeah.
They've included them in the ISO files. So
okay.
Those files expanded quite a bit.
I was going to say it's amazing. Used to be three ISO files. Now it's 7.
Wow, there's a lot of software there, a lot of really good software there, but it's a lot of software, that's for sure. All right, well, this is your last chance. Anybody have anything else before we sign off? I think we're good. Yeah. All right. Well, as always, especially on a Friday, I want to thank everybody for taking the time to join us. Really very helpful. And it really got me a little jazzed about some of the new things. And I always like to also point out that if you ever wonder if the Ansys developers are working, they're working very hard. They're not just fixing bugs; they're adding capability all the time. And if you have capability enhancements, you should definitely don't assume somebody else has brought it up. Definitely make sure you let your support provider know that you've got a feature or a capability you'd like to see in there, and they keep track of all that stuff. And when it all gets big enough, there's enough demand for it, they'll add it in and they'll find somebody to do it. So don't hold back on asking for stuff, I guess is my point. So, all right. Well, thanks, guys. Everybody have a great Valentine's Day, and it's a 3-day weekend as well. So please do enjoy your 3-day weekend. Woo-hoo. Talk to you guys later.
Okay, bye.
Thanks, Eric.
Bye.
Thanks.
As always, a very informative discussion. And as always, we recommend you go into the documentation and check out the release notes for the products you use. There may be features in there that you have been hoping for, and they're now available. Or maybe there's something in there that is enough to justify getting back on Tex. Maybe you're using an older version of Ansys and you need that new capability. So check it out. And if you have any questions, do reach out to SW support software support, SW support at PADTinc.com with any questions you might have, and we'll try and answer them for you. So I'm going to switch gears a little bit and talk about something we do at PADT that you may not be aware of. PADT's product development team has a group of dedicated engineers that work on medical device simulation and product development. The medical device industry has very special requirements, and the material is complicated. And sometimes it's like blood vessels and muscle and stuff like that, as well as kind of some special materials because they need to be able to work with the human body. So some expertise is needed for simulation in this area. Also, designing something in the industry requires some special knowledge and expertise, especially around quality. That is why several large multinational corporations and a bunch of startups come straight from the operating room to come to PADT. We work with our medical device customers to define specifications, develop preliminary designs, simulate to drive the designs, test, and then create detailed designs that are ready for manufacturing. We can also conduct verification and validation runs using simulation, all within the structure of the customer's quality management system. We can provide simulation support, prototype concepts, or do a complete product from idea to assisting in the first run manufacturing. We've done dozens of devices that are used around the country to help make surgeries more efficient, make knee replacements more robust, and make wrinkles go away longer and with less pain. So there's almost no part of the body we have not dealt with over the years. And yes, we've dealt with those parts. So if you are in the medical device space and you need experts, you can effortlessly integrate simulation, 3D printing into the design process. Please reach out to PADT at info@PADTinc.com or give us a call at 480-813-4884 and let us know you need to talk about medical device design or simulation. So that's our commercial for today. Let's take a look at the Ansys stock. So Ansys did release their Q4 2024 financials yesterday, February 19th. And sadly, I'm kind of really upset about this. This will be the final Ansys quarterly report because they say in the second paragraph that they aren't going to do these anymore, that they expect the regulatory approval for the acquisition by Synopsys to go through by the middle of the year. And so they're not going to be doing a Q2 financial report. They'll be rolling it into whatever Synopsys does, which we'll have to learn about. So join me with a little bit of moisture in my eyes as we go through the final ever standalone Ansys financials review. And it was pretty good. Revenue for Q4 was $882K, and their profit was $282K, or 31% profit and 40% before taxes. Then compare that to Q4 in 2023. That is a 9.6% growth in the revenue and a 2.9% growth in profit. So that's pretty nice. For the year, revenue was at $2.5 billion. Yes, $1 billion. That's up 12%. And profit was $500 million, $576 million. That's a 15% drop in profit. So the year was good. 2.5 billion, 576 million in profit. Most of that growth in revenue came in increased leases, which was kind of interesting. They didn't break it down by products, so I'm not sure which products are being leased more. But yeah, some nice growth there. So they did break down some things a little bit differently this time, which was kind of nice. Hopefully they'll continue to do that going forward. There are, if we look at revenue, where it came from, in 2024, 37.3% of the revenue was from leases, and 12.4% was perpetual licenses. And then just under 50%, 47.5% was maintenance, right? So if you're leasing, 20% of the lease cost is maintenance. And if you buy a perpetual license every year, you got to pay 20% of that perpetual license fee as well. So both are rolled into maintenance, whether you lease or not. And only 2.8% was for services. So a small part of the business. From a geography breakdown, again, 2024 revenue, 51% was in the Americas, both North and South. They don't break it down by which countries, but I suspect that the bulk of that was in the US, but don't really know how much. 25.8% was in Europe, Middle East, and Africa. And the biggest country there was Germany. So 8.2% of the total revenue for the world was in Germany. So significant. And then 23.3% was Asia Pacific. And in that region, the big contributor was Japan at 7.3% of the total for the whole world. So kind of interesting how that broke down. Not a huge amount of change over time, but Ansys usage is very strong in North America and South America. And we continue to see growth around the world. So looking at what they call annual contract value. So when they book something, when they actually count the money can get complicated. So the annual contract value is, somebody bought $1 million worth of Ansys. That's going to cost them $1 million over a year. When they pay, maybe something different, but that's what the annual contract value is. And they broke it down by industry, which is really interesting. So they put 31% of that annual contract value into what they call high tech. And that's semiconductor manufacturing, that's electronics, that's stuff that's basically got transistors in it at some point or somewhere, right? The second largest one was 22% for aero and defense. 18% was automotive. 8% was industrial equipment. Another 8% was energy. 5% was materials and chemicals. 3% academics. 2% healthcare, and 1% construction. So you can see that the growth in automotive over the years has been significant. So over half is in those three industries of kind of the high-tech electronics, 31%, aero and defense, 22%, and 18% for automotive. So that's the bulk of where the revenue comes from. So last but not least, I look at cash, although they're not going to buy. I like to look at it because do they have money to buy somebody, right? I doubt they'll buy anybody before the acquisition. That'll probably screw up the regulatory things and paperwork. But just so you know, it went from $860 million at the end of 2023 to $1.5 billion at the end of 2024. So a lot of cash came in, right? When they book stuff, it's not necessarily it shows up on the P&L when they book it, but when they actually get paid is when it shows up in cash. So they got a lot of money in 2024. That's a big growth. It's almost not quite doubling their cash. Their long-term debt is $754 million. So that gap between cash and debt is much bigger now, which is good. So I might as well take a look at Synopsys, since that's going to be the thing next time, or in November, hopefully. They have a year in October, which is why I say November. So they go November 1st through October 31st for their fiscal year. So they'll put out the numbers in November. So if we look at those numbers, they had $4 billion in cash on Halloween of 2024. So quite a bit. Ansys $1.5 billion. Synopsys will have $4 billion. But if we go back to the announcement of the acquisition, Synopsys is going to borrow $16 billion and then use $3 billion for cash. So that leaves them still plenty of money between the Ansys cash and the Synopsys cash, and they probably add to their cash during the year. So good stuff. There's plenty of money. My point is that there's plenty of money to buy somebody. So that's good to know. So that's it. Sad. When we talk in November, we'll try and figure out. Hopefully Synopsys will break out the old Ansys business so we can take a look at it and see how it's doing and not lump it in with these gigantic semiconductor sales that they do and kind of wash it all out. So anyway, kind of sad. So no more ANSS. If you want to learn more about all of this and actually see the numbers that I'm talking about rather quickly, you can go to investors.ansys.com site. That's the site, and see it all for yourself. Let's also take a look at the stock price. It finished up yesterday on the 19th at $336.74. It did go up to $360 in January, which was kind of matching the 52-week high. But it's still below that $390 that Synopsys offered to buy at. So we might as well talk about Synopsys stock as well. They are at $502 a share, which is flat for a year to date. It's kind of gone up and down a little bit since the year started, but it's only, just coming up on 2 months. But if you look at the last 12 months, trailing 12 months, they're down 8.23%. So they're down a little bit. But you can see why they were able to buy Ansys. Their 5-year growth of stock price was 224%, whereas Ansys only went up 16.82% over those 5 years. And something that kind of hurt my brain is 5 years means 2021 to 2025. Yeah. So the S&P 500 for comparison is up 81%. So definitely Synopsys killed compared to S&P 500, and Ansys is quite a bit below the S&P 500. So you kind of see what's going on there. So, okay, that's it on financials. Let's take a look at the news. It's light on news because they're in a blackout period before they release their numbers, so they don't really say much. Of course, the big story that did come out is that the 2025 R1 release is done. We talked about that. Last month, we talked about kind of the final hurdle with the EU with selling off one of the Red Hawk products to make the EU happy. So that's out there. They also released something that many of you might be interested in. And I don't know what the relationship is, but they've increased the relationship with Concepts NREC. That's a consulting company that has some software products around turbo machinery. And they've released an automated workflow for turbo machinery. We've not looked at it yet, but we have known the folks at Concepts NREC for a very long time and really like them. We have high expectations for this tool. If they did a tool, it's going to be good. They do great work. So if you work in turbo, check out that press release. Check out the Concepts NREC site and give it a look. It might really speed up your design process, your simulation process. PADT news, really boring. We got nothing to report. I will take this point in the podcast to point out that we just posted 3 positions. We haven't had a lot of openings job-wise for a while, but we are growing on the Ansys side of things. So we have 2 account managers for Ansys software sales. One would be based out of our Albuquerque office in New Mexico. So if you know anybody in the Albuquerque area or somebody that wants to move to the Albuquerque area, to have them check that out, especially if they got experience working with the labs. And then we also have an opening for an account manager in California. So this would be a work from home position because we don't have an office there anymore. But it would be covering parts of California. So that is also available on our website. And then from an engineering standpoint, those are 2 sales positions we have open. We just post a job for an antenna application engineer, and that would be working here in our Tempe office in Arizona. So if you know anybody that's an antenna person or account managers that want to sell Ansys software, have them check out www.padtinc.com/careers. Or if you're interested, right? Maybe you. So definitely reach out. So Ansys blog, this is what part of the podcast, if you're a new listener, where I pick 3 posts to the Ansys blog that I think are worth you going and reading. So these are things I liked. And there's a whole slew of blog posts on 2025 R1. So the different project managers or product managers, I should say, in the different products in Ansys have kind of given their opinion or written some pieces. The one that I recommend of all of those, because I'm really fascinated by it, is what's new with Ansys Minerva SPDM. So this is a data management tool. So simulation product data management. It's called Minerva. That's been around for a little while. If you haven't looked at it in a while, I haven't looked at it ever, I recommend you check out this article. It really kind of helps you understand where it fits into your process and how it can be a huge help in managing your simulation data. And we don't talk about Minerva enough. I don't think people really pay as much attention to it as they should. We use it here in our groups. So definitely check it out. And let us know if you have any questions about that. So it's called 2025 R1, What's New with Ansys Minerva SPDM. The next article I recommend is Samtech and Ansys. So Samtech does electronic stuff, and it's called Samtech and Ansys Simulating for a Smaller, Faster, Denser World. I don't know about you, but what we deal with a lot here in our consulting team is putting more power in smaller packages. And this article is just all about that and about how this company, Samtech, is using Ansys to get things done with dealing with that smaller, faster, denser world. So check that out. And then the other thing that Ansys has kind of been adding is these employee spotlights. They have different names for them, but it's really like meet this person that works in Ansys. And I really found this one really interesting because it shares the story of someone in the technical support side who transitioned to sales. And I know we've had folks in our company that have done that. We like to hire salespeople that came from tech support or engineering. So I thought some of you who are listeners that may be contemplating if they want to get into sales would find this really useful. It's called Employee Spotlight, Stella Kaniru's Journey from Technical Support to Sales Success. So check that out if you're contemplating such a thing or know somebody that is. Over on our blog, we actually don't have a lot. It's Ansys certification time. So our Ansys tech support team is off. Every year we have to go through all the products that we support and take a test. And Ansys certifies us as being able to support the tool. So they're off doing that right now. So not a lot of blog posts. Right before he started on his certification, Joe Woodward did get a great post on tech. It's a tech tip called Tech Tip Combine versus Split Body and Ansys Space Claim and Ansys Discovery, which kind of talks about those two tools and the difference between them. So if you're chopping up bodies for hex meshing in Space Claim or Discovery, check that article out. It's actually very useful. And then also Cynthia, who has been on the podcast a couple times, so you should know her as well, summarized some time we spent down in Tucson with some Ansys folks at Arizona Photonics Days in January. So Ansys gave a presentation. We talked a little bit. It was great to meet with folks in the optics world there. So webinars, those PADT will get our webinars scheduled for 2025 really soon. Right now, we're still finishing up the certification, and that's how we decide which ones we're going to do when we finish the certification. And if you go to our events page, you can see what events we've got going on. And just to summarize some that you might be interested in, coming up on the 25th. So if you're listening to this on I'm going to get this out probably about tomorrow, which is going to be the 21st. So on the 25th, we're partnering with LSAS Tech, who are experts in the Ansys mission simulation tools, the STK tools. We're going to be doing a workshop with them in our Denver office called LSAS Tech and PADT Present Space Simulation Workshop. There's one in the morning, one in the afternoon. We'll feed you lunch in between. It's in our Lakeview, Colorado office and right outside of Denver there. And we'll be talking about some HFSS stuff and some other things, and they'll be talking about some STK stuff. So definitely check that out. I'll be at the Arizona Space Summit on March 20th. So next month. So if you're here in Arizona and you care about the space ecosystem, come out to that. ASU is putting it on again this year. This is our third annual one. It's a great event. About 200 people show up for that. Then speaking of space, in April, we will be in the Arizona booth for the 40th annual Space Symposium in the Arizona Space Industry booth. We'll be in booth 640 at the Broadmoor there. It's a great event. If you've ever been to the Space Symposium, you know that. If you haven't been and you work in space, you need to go to the Space Symposium. It's great. We'll be at Tech Connect World 2025 in June from the 9th to the 11th. So this is the folks doing SBIRs and things like that. And then I will also be at the Turbo Expo in June from the 16th to the 20th. And that is pretty much it through June for our events. And that's it for the podcast. Please do like us on whatever podcast tool you use. Please do subscribe and let people know about it. Also, if you want to get our newsletter, go to padtinc.com/opt-in and sign up for the newsletter. Spread the word, let people know about the podcast, and don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 134. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of our current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.